All right, welcome to Measuring Instruments Unit 5. Again, please put your name on the top so I know who you are. And we're moving on to the next unit, which would come up in the provincial exam. So measuring instruments. We have Casey's a wardrobe supervisor in Victoria. She uses a tape measure. Nate is a millwright in Whitehorse. He measures with a vernier caliper. Van is a chef in Yellowknife. He uses a scale. What are some other measuring tools that people use at work? Well, some other tools are protractors, squares, levels, weigh scales, measuring cups, transits, hurdle wheels, speedometers, voltometers. What are some measuring instruments or tools that you use at home? You could use a thermometer, tape measure, ruler, kitchen scales, measuring cups, spoons, all that kind of thing. All right, so we're gonna move on to our getting started. Circle the greatest measure. So in A, the biggest kilometer would be 12. In B, the biggest gram would be 10.9, because 0.9 is bigger than 0.5 and 0.7. In C, a half is bigger than a quarter or 3/8. And in D, 0.1 of a centimeter is bigger than 0.1 or 0.001. Okay, is each statement true or false? 5.246 kilometers to the nearest kilometer is 5. That would be true. 26.4 is close to 27. It actually goes down to 26, so that's false. 0.596 is nearest to 0.5. No, false. That'd be 0.6. 7.298 to the nearest hundredth is 7.3. That's true. So if you look, this rounds, since it's higher than 5, this goes to a 3. This is higher than 5 and higher, so that goes to a 6. This isn't higher, like a 5 or more, so it stays at 26. And this isn't 5 or more, so that stays to a 5. That's why rounding, if it's 5 or more, you go and you round up. All right, so evaluate. We have some fractions here, 3/8 plus 1/16. To do this, we need to make the same denominator. To do that, you have to times this side of the formula by 2. So times this by 2 and this by 2, you get 3 times 2 is 6, and 8 times 2 is 16. Bring that 1 down. So now we can go right across. What's 6 plus 1? Well, that's 7. 7 over 16. The denominator you don't add. Let's go on this side. Oh, they're not the same. They have a common denominator of 32. What do you do to 16 to make it 32? You times it by 2. What you do to the bottom, you got to do to the top. What's 5 times 2? 10. Bring that 1 down from here. 10 over 32 minus 1 over 32 is 9 over 32. All right, evaluate the bottom here. Well, now we're multiplying. With multiplication, you don't need a common denominator. So 1 times 1 and 4 times 12, you just go across. 1 times 1 is 1. 4 times 12 is 48. Same with this one. 2 times 1, go across and go across because it's multiplication. 2 times 1 is 2. So it's 2 over 36. Now, you can simplify this into 1 if we half it. Half of 2 is 1. Half of 36 is 18. 1 over 18. Number 5, express each ratio as a percent round to the nearest decimal place. So 3 divided by 8 in your calculator is going to give you 37.5 because we're timesing by 100 to get a percent. 5.4 divided by 9.8 is 55.1%. Because you have to times by 100 to get a percent. Should remember that from early years school, I guess. Okay, we're moving on to the next page. Natalie is decorating a bedroom with those dimensions on the side. She's gonna put wallpaper border around the top of the room. What length of wallpaper border does she need? Well, they give us the formula. P equals 2 times length times width. So that is 2 times length is 4.4 plus the width is 3.8. So in your calculator, 2 bracket that, close bracket, and it will give you if you want to do it in separately, you could go 2 times, what do these two add up into? 8.2. And then your answer, final answer, will be 16.4 meters. That's how much wallpaper she'll need. How much hardwood flooring does she need? Well, that's length times width because we're dealing with an area. That would be the surface of the ground, which would be an area. 4.4 times 3.8 equals 16.72 meters squared. That's how much flooring she would need. The diagram at the right represents a skateboard ramp. Awesome, I used to skateboard lots. How long is the ramp to the nearest tenth of a meter? Use Pythagoras. Okay, we know that. So we have a squared plus b squared equals c squared, right? So that's 3.5 squared plus 2.0 squared equals c squared, but I'm gonna bring that square root to the other side. So we got 12.25 plus 4. So 12, that's 16 point something. So that'll be 16.25. Square root of that is 4.03. So we can say about 4. So this will be about 4. Awesome. Moving on to 8. A water storage tank has the dimensions shown. What is the capacity of the water storage tank to the nearest cubic meter? So we have a capacity would be measured in volume, like a cup of water. How much volume of water is there? The formula is pi times r squared h. Pi times radius, which is a half of the circle, squared, times h, which is the height of the cup, which is 10. So that will be, let's put that in our calculator and see how it works. Okay, we have pi, that looks like that, times 5 squared times 10 equals 785 meters squared, because it's all in meters. Or cubed, I guess. Cubed, yeah. Volume is in cubes. Awesome. A water truck is used to fill the tank when it's empty. The water truck has a capacity of 4,000 gallons. How many truckloads of water are needed? Okay, well, this is gallons, this is meters. We have to convert, but we're given the hint. 1 meter is 219. So to convert it, we have to take this number times 219. So why did I just put a 2 there? We got to put 785 times, so 1 meter cubed is 219.97 gallons. That will give us a total of 172,764 and 034 and change. So A water truck has a capacity of 4,000 gallons. How many truckloads? How many trucks? Well, all we got to do is take our big gallon divided it by how many trucks. One truck's at 4,000, so let's do it. 172,764. I'm just going to ignore the decimals. Divided by 4,000. It's going to be about 44. It's 43.2, but we can't have 0.2 of a truck, so we'll have to bring a 44th truck. 44 trucks. Awesome. So that's kind of the intro to this chapter. Next video we're going to be dealing with is precision. And then this unit in general is about precision and measuring instruments and how to measure things, how accurate things are, how precise things are. So, oh yes, and understanding uncertainty. When you measure how much percent chance there is to be wrong. So there's no formula sheets, and it's just working through the sections. So we'll continue on in the next video.